Hi students, good morning to all of you. Today we are going to discuss about the topic of cooling of transformer and methods of cooling. Next topic is the cooling of transformer. Next topic is cooling of transformer, and methods of cooling. Okay, cooling of transformer. Cooling of transformer. What is cooling of transformer? Why we are cool the transformer? Cooling of transformer is it is the process by which heat generated in the transformer is dissipated to the environment or in the open area to protect the transformer, So this can be achieved by various cooling methods of transformer. This can be achieved by various cooling methods of transformer. So who are the responsible or who are the major factor cause of generation of heat in the transformer is losses. The major factor for the generation of heat in the transformer is losses, various losses. What are those losses? Hysteresis loss, eddy current loss, and copper losses. Hysteresis loss, eddy current loss, and copper losses. When we control the losses, automatically dissipation of heat is controlled. And next one, in these three losses, hysteresis losses, eddy current losses, and copper losses, majority of losses contributed by the copper losses only. Majority of losses contributed by the copper losses only. Most amount of heat dissipated or occur in the transformer due to the copper losses. What is the formula of copper loss? I square R. In case if the temperature of the transformer will continue to increase rapidly, what will happen if it does not taken the any remedies to control the heat or to reduce the heat? What will happen here? The temperature which is increased in the transformer causes degrading of the insulating material. Degrading of the insulating material. So when the degradation of the insulation used in the transformer, resulting in the damage of the various parts, and take a short circuit or failure of the transformer. If it does not taken the any remedies to control the temperature or to reduce the heat of the transformer, so this causes the damage of the insulating material. When the damage of the insulating material, there may be a short circuit between the primary winding and secondary winding. So that's why we have taken the treatment or proper removal to remove the heat from the transformer. To remove the heat from the transformer. When we remove the heat from the transformer should work efficiently. The life of the transformer is also increases and the efficiency of the transformer is also increases. Due to the losses here, the efficient working of the transformer is reduced. The life of the transformer is reduced and the efficiency of the transformer is also reduced. That's why we are increasing the efficient of the working of the transformer, increasing of the life and increasing the efficiency. We are reducing the losses. So when we reduce the losses, automatically heat is also reduced. And next, one more important part, that heat is also cooled by the various agents. So different types of cooling methods, cooling mediums are there to control the heat increase in the transformer. So the various coolants are used for the cooling purpose of transformer. What are the various coolants are used? The first one is the natural air. And second one is the synthetic oil. And third one is the mineral oil. And fourth one is the gas. And fifth one is the water. Here five coolants are used for the purpose of cooling of transformer: air, synthetic oil, mineral oil, gas and water. Gas and water. Okay. Basically. Okay. What are the different types of cooling methods? See that. Here, basically, there are two types of transformers are there. So that here. Basically, there are how many types of transformers? Wait. Wait a minute. No? Wait. Basically, there are two types of transformers. One is dry type, and another one is the oil immersed type. Basically, there are two types of transformers. One is the dry type of transformer, and one is the oil immersed type of transformer. For cooling of transformers, the following cooling methods are listed below. What are those following cooling methods? For dry type of transformer, we have two methods are there. For dry type of transformer, we have two methods are. What are those two methods for dry type of transformers? One is air natural method, and one is air forced method. Air natural method, air forced method. These two methods are comes under the category of which type of transformer? Dry type transformer. And another five cooling methods are there. So those five cooling methods are comes under the category of oil immersed type transformer. Oil immersed type transformer. What are those five methods are there? See that here. Oil natural, air natural. Oil natural, air natural. Second one, oil natural, but air is forced. Air is forced. And third one is the oil force, air force, oil force, air force. And fourth one is the oil natural, but water force, oil natural, water force. And fifth one is the oil force, water force, oil force, water force. See that here, these five methods are applicable to the oil immersed type of transformers. What are those five methods? Oil natural, air natural, oil natural, air force, oil force, air force, oil natural, water force, oil force, water force. These five are comes under the category of oil immersive type of transformer. And next come to the point of dry type of transformers having the two methods, air natural and air force. Air natural and air force. So these are the basic methods which are used for cooling of the dry type transformer, for cooling of the oil immersive type of transformer. Dry type transformer and oil immersive type of transformer. Next, methods of cooling which are applicable to the dry type transformer. So here dry type transformer are having the two cooling methods are there. One is the air natural and one is the air force. It is also called as air blast. It is also called as air blast. Let us now we are going to discuss about the oil natural, air natural. Discuss about the air natural. Air natural method. Air natural method is nothing but in this method, the heat which is generated in the transformer, the heat which is generated in the transformer is cooled by the circulation of natural air, by the circulation of natural air, by the circulation of the by the circulation of the natural air in or air natural method. The heat which is generated in the transformer is cooled by the circulation of natural air. Dry type transformer means the transformer core and the windings of the transformer, they are not immersed in the oil tank. They are just placed in the empty tank. They are just placed in the empty type of the tank. Next, when the temperature of the transformer, so when we are going to cool the heat which is occurred in the transformer, when the temperature of the transformer becomes higher as compared to the surrounding, as compared to the temperature of the surrounding air, as compared to the temperature of the surrounding air. You know that the heat transformation can be done in three ways. One is conduction, and one is convection, and next one is the radiation. Conduction, convection, and radiation. The heat can be, in according to physics, the heat can be transferred in three ways: conduction, convection, and radiation. Thus, by this process, the natural convection process, the heated air is replaced by the cool air. The heated air is replaced by the cool air. So here, with the help of natural air, we are cooling the transformer core and transformer winding in the dry type transformer. That method we call as the air natural method. Air natural. It is also called as self-cooled method, which is also called as self-cooled method. Which type of cooling method we call as the self-cooled method? Air natural method. This method is applicable to which type of transformer? Dry type of transformer. And next one, this type of method is applicable to the dry type. What is the ratings of the transformer up to 1.5 MVA? 1.5 MVA, the ratings. So air natural method of cooling is applicable to the dry type transformer up to the application. What is the rating of the transformer? 1.5 MVA. 1.5 MVA. And next come to the point of next method is the air force or air blast. Air force or air blast. So the title itself given the idea, we are we are sending the air into the transformer tank with a forcefully, with forcefully. That is, in this method, the heat generated is cooled by forced air circulation. Forced air circulation. How that forced air circulation is applied to the transformer is nothing but with the help of fans, blowers, and high velocity air. With the help of fans and blowers, the high velocity of the air is forced on the core and windings of the transformer. The high velocity of the air is forced on the core and windings of the transformer. So when the high velocity of the air is forced on the core and the windings of the transformer, the temperature inside the transformer goes beyond goes beyond to the safe level. Safe level. And next one, here there is a automatic connection is also. So here, when the temperature which is occurred in the transformer is greater than the surrounding temperature, then the alarm is activated. When the alarm is activated, the fans and blowers are automatically switched on. The fans and blowers are automatically switched on. This type of method is used for dry type transformers of rating up to 15 MVA. 15 MVA. Very, very important. Here, five competitive questions are there. Air natural method and air force or air blast methods are applicable to dry type transformer. Air natural method can be used up to the transformer ratings of the 1.5 MVA. Another name of the air natural method is the self-cooled method. Self-cooled method. And next one, in air blast or air force, how we are cooled down the transformer core and the windings by forced circulation of air. By forced circulation of the air. And there is a automatic operation. How? By setting the alarm. By setting the alarm. What is the application of the air force or air blaster of the transformers up to the 15 MVA. Up to 15 MVA. This is about methods of cooling of transformer for dry type. Which type of transformer? Dry type transformer. And next come to the point of oil immersed type of transformer. Oil immersed type of transformer. In oil immersed type of transformer, in this type of transformer, this transformer core, see that here, in oil immersed type of transformer, the transformer core and the transformer windings are immersed in the oil filled tank. Immersed in the oil filled tank. So these type of transformers can be used up to the ratings of this type of cooling methods is used up to ratings of 60 megavolt amperes. What is the rating of the transformer? 60 megavolt amperes. So here in natural oil, oil natural, air natural method. In this method, the dissipation of heat is taken place with a convection process. In this method, the heat dissipation process is taken by convection process, in which in this process the air is naturally circulated to cool down. The air is naturally circulated to cool down. But in this type, forced air is used for the purpose of cooling the transformer. The forced air is used for the purpose of sorry. Sorry, ma, sorry, sorry. So the next topic is the oil immersed air natural. Oil immersed and air natural. So oil immersed type of transformer is nothing but in this type of transformer, the transformer core, the transformer windings are immersed in the tank, oil tank, immersed in the oil tank. So in this type of transformer, the natural convention process is used to the natural convention process is used for cooling of the transformer. For cooling of the transformer. See that here in this the tank. So this tank. So in this transformer tank consisting of core and windings, they are placed inside the transformer tank in the oil. And next one, the radiators are at the right side and left sides of the transformer. The radiators are arranged at the right side and left side of the transformer. Here, due to increasing the temperature or increasing the heat, the level of oil should be increases. The level of oil should be increases. When the level of oil should be increases, here it enters into the radiator tubes. It enters into the radiators. These radiator tubes are exposed to the atmosphere. These radiator tubes are exposed to the atmosphere. So the air which is blown outside the radiator tubes, the air which is blown outside the radiator tubes, these air cool down the transformer oil. Cool down the transformer oil. So like this, the oil will be cooled in the transformer tank with the help of radiators naturally, with the help of radiators naturally. So that's why these type of cooling method we call as oil natural, air natural, oil natural and air natural. What is the rating of the transformer applicable to 30 MVA? Up to 30 MVA. So this type of transformer is used up to 30 MVA. Oil natural is the 1.5 MVA. Oil blast or that is air natural is the 1.5 MVA. Air blast or air force is the 15 MVA. Oil natural, air natural is the 30 MVA. Double 30 MVA. And next see that the next method is oil natural but air is forced. Oil natural, but air is forced. In this type of transformer, same. In this type of transformer, same. Here, the more amount of heat is present in the transformer oil. The more amount of heat is present in the transformer oil. So the natural air blown does not sufficient to cool down the oil inside the radiators. The natural air is not sufficient to cool down the oil inside the radiators. So that's why externally we are arranging the some special arrangement. We are arranging the some special arrangements. What are those special arrangements? Why we arrangements are we are arranging the fans or blowers. Fans or blowers at right side and left side of the radiators. We are arranging the fans or blowers at right side and left side of the radiators. Due to arrangement of the blowers, the velocity of the air is very high. The high velocity of air is forcefully applied to the radiator and cooling the radiators, which help in the oil to cool more quickly and efficient. So here, oil natural, but air force. In this method, the only changes are to cool the oil as fast as possible. We are arranging the blowers or fans at the radiators of the transformer at both sides, right side and left side. So due to this, we are easily cool down the temperature of the oil, easily cool down the temperature of oil with a span of time or less time. So with that, we are increasing the efficiency of the transformer and longer life. And next one is the efficient working. Efficient working. So these are the two methods of oil natural, air natural, oil natural, air force. Oil natural, air force. Next three methods are oil force, air force, oil natural, water force, oil force, water is also force. Next three methods are okay, students. The next three topics are explained in the next view, continued in the next view.